Second section of 7.2 is basically dealing with the same material that we learned in section 1, but it's called the applications of linear equations. What it means is if somebody just doesn't give you an equation, if you actually have, where would you actually use what we learned in section 1? And basically they come down in math to word problems, because in the real world you use words to describe things, not just initially an equation. They would, so anyway, they're word problems. We just have to, and of course that's something people you've struggled with for quite a while, so it's for a lot of people. Okay, so let's just look at a couple of examples. So the first problem is problem 18. And the section of the homework says let x represent the number, write an equation for the sentence, then solve. So we just need to come up with a, this is kind of the simplest version of coming up with an equation based on words instead of numbers and letters. So it says if 4 times a number is added to 8, the result is 3 times the number added to 5. So the number is x. So in the sentence, wherever it uses the 2 words, the number, we put in x. So, and the if thing is really just telling you that it's going to be an equation. So it says if 4 times, I use a little dot here, a number is added to 8. So in terms of the sentence there, 4 times a number is added to 8. So I put 8 first. It doesn't really matter if I do 4x plus 8 or 8 plus 4x. The result is, so it's, what does the result is means? The result is equals. So it means equals, or the, okay, so equals. The result is 3 times the number added to 5. And again, I'm going to move this over here because that's 3. You could, it's the same as 5 added to 3 times the number. It doesn't matter, you know, the order of operations. So that's what the sentence is. So look at it. 4 times x, or 4 times a number, which is x. 4 times x is added to 8. The result is 3 times x added to 5. So now I've got an algebraic equation. I just have to solve for it. So once you have the equation, the rest of it is just like section 1. I've taken the times out here and just used the short term, which is 4x is the same as 4 times x. So what do we do? Well, we've already combined, like, there's no like terms to combine. We've got a constant, we've got the variable part. So now we just have to solve for x. So the first step is to move all terms that involve constants to the right-hand side, all the terms that involve x to the left-hand side. So we do that by subtracting 8 from both sides, so that 8 minus 8 is 0. That's going to eliminate it from this side, but I balance it by subtracting 8 from the other side. And then I go here to the right-hand side. I want to get rid of 3x. I want to move it to the other side appropriately. So I'm going to subtract 3x, and I have to do that to both sides. So again, here's my original equation. I'm adding, in this case, subtracting quantities, the same quantity for both sides. This is basically 0 equals 0. So I'm not really changing the equation at all, except its appearance. Okay, so let's just go through it. So 8 minus 8 is 0. 4 minus 3 is 1. So I get 1x. 5 minus 8 is negative 3. 3x minus 3x is 0. So don't write those down. And so the answer is the value of x, where that is true, is x equals negative 3, which is a great answer. Okay. 21. Let's see what 21 is. Another kind of thing. So it says the sum, so I'm going to put a little plus sign here. The sum of 3 times a number and 7 more than the number, sum of 3 times the number and 7 more than the number. Okay, that's a little tricky. So if it just said the sum of 3 times the number and 7, but it's 7 more than the number. So what you do is you have to put that little part in parentheses, 7 more than the number. So the sum of 3 times the number plus 7 more than the number is the same. So before we had the result is, that was equals, is the same as equals as the difference. So it's going to be difference, we'll subtract. The difference between negative 11, so negative 11 is the first term, and twice the number. So let's just check this out again. The sum of 3 times a number and 7 more than the number is the same as the difference between negative 11 and twice the number. Okay, so that looks reasonable. I'm going to move these things up to the same line. So now I've got my algebraic expression. First thing we'll do is just get rid of the parentheses. Next thing we do is combine like terms, and the only 2 terms that we have to do that to, these two, 3x plus 1x is 4x. I want to go ahead and switch the order of those. So it doesn't matter. Once I've got it as an equation, I have negative 11 plus a negative 2x. I can move the 2x ahead of time. And I don't really need to do that. I just want to have variable, constant. Okay, now we need to solve for x. So what we're going to do is we're going to subtract 7 from both sides. And that's going to make this go to this right-hand side. Left-hand side is just going to have a variable. It's going to go to 0. I'm going to add 2x to both sides so I can get rid of that term on the right-hand side. So this is going to be eliminated on the right-hand side. It's going to be eliminated on the left-hand side. 4 plus 2 is 6. I get 6x is equal to, this goes to 0. This goes to 0 is negative 18. And then I divide both sides by 6, which is the constant in front of x. So I can solve for x. 6 over 6 is 1. 1x is just x. And I get negative 3. And so that's the answer. Okay, so that was 21. I think I wrote it down, but it is 21. And 23 is the next one. So use the methods of examples 1 and 2 or your own method to solve each problem. Concert revenues. John Bon Jovi and Bruce Springsteen had the two top grossing North American concert tours for 2008, together generating $415.3 million in ticket sales. If Bruce Springsteen took in $6.1 million less than Bon Jovi, how much did each tour generate? So how do we solve this particular thing? We have to come up with some equation. And the first thing to do is to assign a variable. So I'm going to use J for, we're going to call that the gross ticket sales. For Bon Jovi. It's J because Bruce starts with a B. It's Bruce Springsteen. Gross ticket sales for Bruce Springsteen. So the total ticket sales, J plus S, is going to be equal to 415.3 million. We're not going to show the million. We just let that carry along. If Bruce Springsteen took in 6.1 million less, so what it says there is that Bruce Springsteen took in the amount that Bon Jovi took in minus 6.1. So Springsteen was 6.1 million less than John Bon Jovi. So this actually involves two variables, but we're still solving for S and J. We're not doing, there's a solution for S and there's a solution for J. It's not like Chapter 8, which will be X versus Y. Right? We can't really plot anything. We just have a solution, one answer. Okay. So when you have two equations and two unknowns like this, there's two ways of doing it. There's substitution and there's elimination. Now, substitution is probably the easiest one to use here because what I do is I substitute one of the variables in terms of the other variable. And I could do it either way, but because this one's already solved for S, I can do it easily. So I take the first equation. Instead of S, I use the second equation to substitute so that it's in terms of the same variable here, J. So that's my original equation. Substituting it for S is J minus. So the parentheses, all I have to do is just remove the parentheses. So I get 2J, touche, and then I'm going to add 6.1 to both sides so that I can solve for 2J. So this plus that is 0, and 415.3 plus 6.1 is 421.4, and then I divide both sides by 2, so that 2 divided by 2 is 1, so I have 1J divided 421.4 by 2, and I get 210.6 million. And then to find out S, I just have to go back here and plug that in. So I get 210.7 minus 6.1, and I get 204.6 million. You see that if I plug these back in, they add up to 415 million, 415.3 million, and that this is 6.1 million less than that. Yeah, I'm just going to put my dollar signs there. Dollars. Okay, so that's 3 problems. I'm doing 3 problems at a time.